Hello everyone. Welcome back to the series of Claude Code for Data Engineers. In the previous episodes, we cleaned invalid rows, removed duplicates, and improved overall data quality. But even perfectly clean data can still have bad reports if records point to references that doesn't exist. Imagine an order belonging to a customer who isn't present in your customer table. The record exists, the order exists, the revenue exists, the dashboard shows the number, but the customer doesn't exist. This is called referential integrity issue. Today we'll be using Claude Code to identify these hidden problems before they impact downstream reporting. So let's start with the basics. Referential integrity means that every value in a child table must have a matching record in the parents table. In our example, customers is the parent table, raw orders is the child table, and customer ID is the key connecting them. If an order contains customer ID 9999, but this customer doesn't exist in the customers table, then order becomes an orphan order. In a transactional database, foreign key constraints would normally prevent this. However, in data engineering pipelines, staging tables often load data without constraints, which allows these issues to slip through unnoticed. So, why this issue is hard to detect? The biggest problem with referential integrity failures is that they usually don't generate errors. The pipeline runs successfully, the data gets loaded, the dashboards refresh, everything appears normal. But behind the scenes, reports are being calculated using invalid references. This can lead to incorrect revenue numbers, inaccurate customer metrics, and misleading business insights. The later we detect these issues, the more expensive they become to fix. That's why integrity checks should happen before data reaches reporting layers. Now let's check the setup here. For this demo, we have two SQL files. The first file is customers.sql. This contains our valid customer records and acts as a reference table. The second file is deduped orders, which we received from a previous deduplication step. This contains orders record that needs to be validated. We launch a Claude code inside our project folder and ask it to compare the customer ID values across both the files. So the objective here is very simple. Find orders that reference customers that do not exist. So before going to the demo, let's check the project folder that we are going to use in this video, where we have input files, that is customers.sql, and deduped orders.sql, which we received from a previous step. Here is our project folder where we have the customers.sql file, which is an input to this step. And along with that, in the output folder, we had deduped underscore orders.sql file, which we received from our previous step, that is deduplication. So for this demo, we'll be using these two files as an input to the Claude code, and we'll see if there is any integrity issues there. And now let's go to the SQL Server and see the content of these SQL files, and we'll look closely to find out if any integrity issues exist. So here we have the insert queries for the customers table. So here you can see the customer IDs range from 1001 to 1008, and I have inserted this data in the table, that is customers table. Let's check the data of this table. So here you can see we have records from 1001 to 1008. Now let's go and check the data that we received from a previous step, that is deduped orders. So here you can see we have around 14 records, and now let's look closely into the customer ID field. So here you can see this one. So you can see record number 11 has a customer ID which is 9999, which doesn't exist in our customers table. Hence, we can say record number 11 has to be removed, that is for the order ID 5010. So this is creating the data integrity issue. Hence, we need to solve this using our Claude Code prompt. So now let's go and check what is the prompt that we are going to use in this demo. Now let's provide Claude Code with a clear instruction. We tell Claude that customers.sql contains valid customer records and deduped orders.sql contains order data. We then ask Claude to cross-reference every order customer ID against customers.sql, separate valid orders from invalid ones, create a valid underscore orders.sql file, create an orphaned orders.csv file with reason, and generate a summary showing counts and missing IDs. This is a very common data engineering workflow. Instead of manually writing validation queries, Claude Code performs the analysis for us. So now let's see the prompt that we are going to use. So this will be copying and we'll go back to the terminal. We'll first reach the project folder and then we'll paste this prompt in the Claude prompt. So this is our terminal. Let's enter the project folder. Let's give the Claude prompt. Yeah, so I'll copy the prompt that we have written. It may take a while to execute. So let's wait. So here you can see Claude Code has finished the execution. So here we can see that we have the matrix here. The total orders and deduped underscore orders were 14. Valid orders are 13. Orphaned order is 1, which we expected. And apart from that, it has created output files as well, that is valid underscore orders.sql and orphan underscore orders.csv. Now let's check these two files and we'll verify our data. So these are output files that we receive from our Claude Code prompt. So here you can see in the valid orders file, we do not have record with the order ID 5010, which was having incorrect customer ID. So here we can see the file is correct. And let's check the next file, that is orphaned orders.orders. So here we can see, here we have the record that was having the integrity issues. So it seems our Claude Code prompt has worked correctly. As we saw, after running the prompt, the Claude returns the results. So we find 13 valid orders, 1 orphaned orders, and 1 missing customer ID and the problem order ID. Claude also generates a dedicated orphaned underscore orders.csv file, which we already saw, which have the orphan record along with the issue related to it. It has also mentioned the reason behind it. So this output can then be shared directly with the source team and or with the data quality ticket. So this significantly reduces the investigation time. So now let's come to the demo 2. So here we are going to check the customers with no orders. So let's go one step further. Most team only checks whether orders have valid customers, but we also perform the reverse validation. We ask Claude which customers exist in the reference table but have no matching orders in this data set. This helps identify missing extracts, incomplete loads, inactive customers, and data synchronicity issues. By validating both directions, we get a much more complete view of data quality. So let's use the same prompt, this one, and copy it in a terminal. So I'll paste the prompt which I just copied. Let's wait for the output. So here we have got the reports of the customers who have not placed any orders yet. So now we want a professional report that can be shared with the stakeholders. We want a professional report that can be shared with the stakeholders. We ask Claude Code to create a integrity report.txt containing total customers, total orders processed, valid customer references, invalid customer references, customers without orders, recommendation for each issue. So instead of reviewing multiple files manually, the team gets one consolidated report. So this makes auditing and communication much easier. So I have copied the prompt already. Let's paste here. Okay, so here we can see what are the metrics which were calculated. So customers in reference table are 8, total raw order rows are 33, valid customer references are 30, invalid customer references are 3, missing customer IDs are 1, customer absent from raw data is 0, customer with 0 clean orders is 2. So this information we can share with stakeholders. So this makes auditing and communication much easier. So when working with Claude Code, prompt clarity is extremely important. Always specify the parent table, the child table, the matching key, the expected outputs, and the reporting format. The more explicit your instructions are, the better the results. A well structured prompt reduces an ambiguity and makes the workflow repeatable. This is exactly what we want in production ready data pipelines. So, where episode 4 fits in the pipeline. So, let's place this step in the bigger picture. Our data cleaning workflow now looks like first episode data processing. The second one was row validation. Third one was deduplication. Current episode is referential integrity, and the coming episode will be reusable pipeline automation. So, referential integrity acts as a safety gate before data moves into analytics and reporting system. Without it, invalid references can quietly contaminate reports. So, let's recap what we completed today. So we completed cross-reference orders against customers, identified orphaned records, generated valid and invalid output files, checked customers with no orders, and created a professional integrity reports. So at this point, we have completed 4 major data quality checks. In the next episode, we will bring everything together. So we'll use a Claude code to package all these validation steps in one reusable Python pipeline. The goal is simple: drop a SQL file in, run the pipeline, get clean, validated, production ready data automatically. Thank you for watching. Then I'll see you in the next episode.